Millions of people around the world deal with endometriosis. It's a condition that causes really severe pain and just makes everyday life so much harder. But what if there was a way to target like the root causes of this condition without being invasive?
Yeah.
Today, we're diving deep into the science behind photobiomodulation, also called PBM, and we'll be focusing on its potential for treating endometriosis, specifically with MedWave's Endo panel.
Yeah, that's right. If you're looking to really understand how certain wavelengths of light could actually help relieve endometriosis symptoms, and that constant pain,
Yeah.
you're in the right place.
That's right. We're going to be looking at the research that suggests PBM could actually make a real difference.
Exactly.
Okay, so endometriosis is definitely not just like a minor inconvenience. It's a really serious health issue for so many people. Can you talk about just how widespread this problem is?
Sure, absolutely. Endometriosis affects millions of people, and as you mentioned, it's characterized by tissue that resembles the uterine lining, but it grows outside of the uterus.
Oh, wow.
Yeah, and this can cause, a bunch of different effects. The most noticeable being like the intense pain and chronic inflammation. But what's really fascinating is how all the different cells in the body work together, to contribute to its development and progression. We're talking about like this delicate balance of immune cells and fibroblasts, which are they're connective tissue cells.
Right.
And this balance, it seems to get messed up.
So it's not just misplaced tissue. It's like a cellular miscommunication.
Yeah.
That makes the problem worse. So let's focus on these key cellular players. Which ones are really at the core of what's going wrong with endometriosis?
Okay. Well, research shows that there's a disruption in the immune response. Think of your immune system as your body's security force. And with endometriosis, some of the important frontline defenders like T cells, which are responsible for targeted responses, and NK cells, which get rid of abnormal cells, they tend to be less effective.
Oh, okay.
But at the same time, we see other immune cells like certain dendritic cells, which are kind of like the messengers of the immune system.
Right.
They start acting abnormally, and we see an increase in plasma cell activity.
Okay.
It's like the security system is weakened in some areas, but overactive in others.
Yeah, it's like the immune system is really confused.
Exactly.
And it doesn't stop there, does it?
No, not at all. Another type of immune cell called a macrophage, it becomes super active.
Okay.
And these activated macrophages, they release signaling molecules like TGF-beta and IL-1, which can further, promote the development of endometriosis.
Yeah.
What's really interesting is the prevalence of what we call the M1 phenotype of macrophages. So think of M1 macrophages as the angry immune cells. They're more pro-inflammatory.
Right.
And they contribute significantly to the inflammation that we see with endometriosis.
So we have these kind of aggressive pro-inflammatory M1 macrophages like stirring things up.
Right.
What else is going on at the cellular level?
Okay. We also see a decrease in the activity of a gene called PTNE, which usually acts as a brake on cell growth.
Okay.
It suppresses tumors, but its decreased presence in endometriosis might be why the endometrial-like tissue grows abnormally.
Interesting.
Yeah, and then when we look at the chemical messengers involved, we see elevated levels of pro-inflammatory cytokines like interleukin-6 or IL-6,
right,
and prostaglandin E2 or PGE2.
Okay.
And they're really key in driving that pain and inflammation that's so characteristic of endometriosis.
Right. So we have all these signals promoting inflammation and pain.
Yes.
And I know hormones play a big role too, right?
Oh, absolutely. There's often an overproduction of estradiol, which is a form of estrogen.
Okay.
And this excess estrogen, it actually fuels the inflammatory response.
Wow.
Yeah, and this response involves those pro-inflammatory cytokines we talked about, like IL-6,
right,
and another one called CCL5.
Okay.
Now, in addition to that, we have endometriosis-associated fibroblasts, which are specialized connective tissue cells.
Right.
And these fibroblasts, they work with the plasminogen activation pathway, and they're involved in how that endometrial-like tissue invades other tissues in the body.
So it's like these fibroblasts are helping the endometriosis like take root and spread.
Yeah, exactly.
And you mentioned signaling pathways.
Yeah.
Are those disrupted too?
Oh, yeah, definitely. Research has found changes in the activity of genes in several really important signaling pathways. These include TGF-beta, NFKB, MAPK, RORAC, and JAK-STAT. You can think of these pathways as like the cell's communication network. They control all sorts of essential processes.
Right.
So any changes in these pathways can have, a ton of effects on how endometriosis develops and gets worse.
So it's really a complicated web of interconnected problems. Immune cells, fibroblasts, hormones, and signaling pathways,
Right.
all contributing to this really serious health problem. Now let's move on to a potentially very promising approach.
Okay.
Photobiomodulation, or PBM. For someone who's hearing about this for the first time, what exactly is it?
Well, essentially, photobiomodulation uses specific wavelengths of light to interact with the tissues in our bodies on a cellular level.
Okay.
You can almost imagine it as using targeted light energy to kind of stimulate or modulate cellular activity. It's like fine-tuning a really complex machine.
Okay.
Now, in the case of MedWave's Endo panel, we're particularly interested in the effects of red light at 635 nanometers and near-infrared light at 810 nanometers.
Okay, so red and near-infrared light. Those are the specific wavelengths that MedWave's Endo panel uses.
Yeah.
Now, one of the main benefits of PBM that we see a lot in the research is its effect on inflammation.
Right.
Why is this so important when we're talking about endometriosis?
Well, because inflammation is, it's really a central factor that drives the symptoms and progression of endometriosis.
Okay.
And, one of the most consistent things that we've seen in tons of scientific studies on PBM is its ability to reduce inflammation.
That's great.
And this is really important for endometriosis because chronic inflammation is, it's a major cause of pain and tissue damage. And what's really notable is that PBM has shown that it can reduce markers that are associated with that pro-inflammatory M1 phenotype in activated macrophages that we talked about earlier.
Right.
It basically helps to calm those angry immune cells down.
So it's directly targeting one of the main players in that inflammatory process.
Yeah.
Are there any specific studies that show this anti-inflammatory effect using the types of light that are in MedWave's Endo panel?
Absolutely. Some research looks at other wavelengths.
Right.
But there's really strong evidence that directly relates to 635 nanometer light.
Okay.
For example, studies using a 635 nanometer LED showed that it caused significant reductions in a few key inflammatory markers.
Oh, wow.
This includes cyclooxygenase 2 or KOX2 and prostaglandin E2 or PGE2, which we know are really involved in pain.
Right.
As well as granulocyte colony stimulating factor or GCSF.
Okay.
RONTES and CXCL11.
Wow.
And this really suggests that 635 nanometer light can have a very powerful anti-inflammatory effect at the cellular level.
That's really good to hear. And the research also suggests that PBM might have effects beyond just the area where the light is applied.
Yeah, exactly. While the light is directed at a specific spot. The benefits may actually spread beyond that localized treatment.
Yeah.
There's growing evidence that shows that PBM can actually trigger systemic anti-inflammatory responses.
Okay.
Which means that light that's delivered to one part of the body could actually have beneficial effects on tissues and organs that are far away and that are involved in the bigger inflammatory processes of endometriosis.
So by reducing these pro-inflammatory markers,
Yeah.
how does that actually lead to pain relief for someone who has endometriosis?
Well, it's a pretty direct connection.
Yeah.
Prostaglandin E2 and interleukin 6, which are both elevated in endometriosis.
Right.
And we know PBM can reduce them.
Okay.
They're also key players in how the body signals pain.
Interesting.
So by lowering the levels of these molecules,
Okay.
PBM can actually directly reduce pain.
That makes sense.
Plus, PBM can also influence all sorts of cellular signaling pathways that are involved in how we feel and process pain signals.
It's like PBM is it's targeting the very sources of the pain by calming down that inflammatory storm.
Yeah, exactly.
Now let's dig a little deeper into how PBM actually does this at the cellular level.
Okay.
We talked about it briefly.
Yeah.
But how does it actually interact with impaired tissue?
Right. Well, it's understood that PBM mainly interacts with the cells in the mitochondria,
Okay.
which are the powerhouses of our cells.
Right.
And this interaction then starts a whole chain of beneficial cellular responses.
Okay.
One important thing is PBM's effect on transcription factors like NFKB.
Okay.
NFKB has, a bunch of different roles.
Right.
But PBM can activate it in a way that actually helps to protect cells from damaging oxidative stress and harmful molecules called reactive oxygen species, or ROS.
Okay, so oxidative stress seems to be something that's common in a lot of chronic conditions, including endometriosis.
Right.
How does PBM help to fix this imbalance?
Okay. Well, in endometriosis, there can be a problem with the balance between antioxidants, which protect our cells,
Right.
and free radicals, which can cause damage.
Right.
Now, ROS are a type of free radical,
Okay.
and PBM's ability to influence NFKB actually helps to restore this balance by boosting the body's natural antioxidant defenses.
Yeah. Right.
And reducing the harmful effects of ROS.
So it's not just about directly lowering inflammation, but also helping the cell's own protective mechanisms.
All right.
And we also talked about how PBM can affect various signaling pathways.
Right. Yeah.
And this is especially important because a lot of these same signaling pathways, like TGF-beta, MAPK, and JAK-STAT,
Right.
they're also involved in how endometriosis develops and progresses.
That's right.
These pathways are essential for controlling really important cell processes, like cell growth,
Yes.
specialization, survival, movement,
Yeah.
programmed cell death, and of course inflammation.
Yeah.
All of which are relevant to endometriosis.
Exactly.
So PBM's ability to kind of modulate these pathways and get them back to a more balanced state is really key.
Yeah, that's right. It's almost like PBM is speaking the same language as endometriosis.
Yeah, yeah.
But with a therapeutic goal.
Right, right.
Yeah.
Are there any specific ways that PBM influences these important pathways?
Oh, yeah. Research has shown that PBM can increase the production of ATP,
Okay.
which is the main energy source for cells.
Right.
And it can also improve the mitochondrial membrane potential, which is essential for the cells to make energy efficiently.
Right.
It can also help to regulate the levels of intracellular calcium, ROS, and nitric oxide, which is NO.
Okay.
All of these play really important roles in cellular signaling.
Okay.
So this really highlights PBM's ability to fine-tune these intricate communication networks that are happening inside of cells.
So more energy for the cells, and it kind of rebalances those key signaling molecules.
Yeah.
How does this actually happen on like a mechanistic level?
Okay. So one of the main mechanisms is that PBM stimulates the release of nitric oxide from an enzyme in the mitochondria called cytochrome C oxidase, or COX.
Okay.
When NO binds to COX, it can actually inhibit mitochondrial function.
Oh.
But PBM can help to reverse this inhibition.
Right.
And it improves mitochondrial respiration, which then affects oxidative stress and the overall cellular signaling.
Okay.
Another thing is that the increase in ATP production that's caused by PBM can actually enhance the activity of ion pumps that transport calcium, potassium, and sodium across the cell membranes.
Okay.
And these ion movements are crucial for cellular signaling, and they can influence the activity of transcription factors like NFKB and MAPKs.
So it really sounds like PBM is targeting some of the core cellular dysfunctions that we see in endometriosis. Yeah, it is.
And this brings us to MedWave's EndoPanel, which seems to be specifically designed to use these scientific findings.
Exactly.
Right.
MedWave's EndoPanel uses both red light at 635 nanometers and near-infrared light at 810 nanometers.
Okay.
To specifically target the cellular mechanisms that we've been talking about.
Right.
This offers a non-invasive way to potentially reduce the inflammation and the pain that's associated with endometriosis.
Right.
By directly addressing these underlying cellular problems.
And for our listeners who are who are really interested in this,
Yeah.
and they're wondering, what their options are.
Right.
How can they learn more about MedWave's Endo Panel?
Well, MedWave's Endo Panel is it's available through healthcare practitioners.
Okay.
So it's an option for in-office treatments.
Right.
But what's really great is that they also have a really convenient at-home device.
Oh, wow. So people can easily incorporate PBM into their daily routines.
Right.
And anyone who's interested in finding a MedWave provider or buying an endo panel for at-home use can go to the MedWave website. They've got all the information there.
Great. So to sum up our deep dive today,
Yeah.
what's the key takeaway about the science of photobiomodulation?
Right.
And its potential for treating endometriosis?
Well, the research is really compelling, and it strongly indicates that that photobiomodulation, particularly using specific wavelengths of red and near infrared light, like the 635 nanometers and the 810 nanometers that are found in MedWave's Endo Panel, has a lot of promise.
Yeah.
It can have a positive impact on key cellular mechanisms that are disrupted in endometriosis, including reducing inflammation and potentially lessening the pain that's associated with it.
Well,
And it does this by targeting pro-inflammatory markers and adjusting those vital cellular signaling pathways.
It's really amazing to think about how this kind of targeted approach with light therapy could be like a whole new way to manage, the challenges of endometriosis.
Yeah.
It really makes you think about, the potential of these non-invasive technologies to help our bodies at like a fundamental cellular level.
Oh, absolutely. And
Yeah.
for anyone listening who really connected with the science we talked about today
Right.
and wants to learn more,
Yeah.
looking into photobiomodulation and MedWave's Endo Panel more could be a really good next step.
Absolutely.
Yeah.
Great. Well, thank you so much for joining us for this deep dive.
Oh, it was my pleasure. Thanks for having me.
And thank you to all of our listeners for tuning in.
Yeah.
We'll see you next time on the deep dive.
See you later.
Bye.